Welcome everybody, and here we are recording again. This is part of our practice exam for Unit 3. This is Section 1, Part B. And for this one over here, we're going to look at number 9. Number 9 says, given that f of x equals x squared, g of x equals the square root of x, and h of x equals negative x minus 1, what is the domain of h of g of f of x? So this is the main thing here. You want to make note of this. H of g of f of x is the same thing as if I wrote this here. Okay? H of g of f of x. So basically what you have to do is you have 3 compositions. That means you have to put a function in a function in a function. So this means I have to first put f in g, and then I'm going to put all of that into h here. Okay? So you notice here, if I rewrite my composition f of g of f of x here, I'm first going to find g of f of x. Okay? And this means I'm going to put f in g. So we first write the outside function. Okay? And g is the square root of x. So the square root of blank, and what goes into blank is f of x. F of x is just x squared. Okay? And we all know that the square root of x squared just gives me x. Okay? So you want to simplify if you can. In this case, I can. So far, I have found the inside here. So I have found g of f of x. G of f of x is just what I get when I put f in g, which is just the square root of x squared, which is x. And now I'm going to put this inside of h. And what is h? We'll write down h. H of x is negative x minus 1. So we put parentheses, and now we're going to write it with a blank. So negative blank of negative 1. And we're going to put in what we got for g of f of x, which is just x. So we're going to put in the x here. So what we end up with is negative x minus 1, which is really just the same thing as h of x, right? So even though it turns out, in this case, h of x is the same thing as h of g of f of x here. And now we have to find the domain of it. And the domain of this is clearly a linear, which if you remember is all real numbers. Or, if you want, you can graph this out. Y-intercept is negative 1. The slope is negative 1 over 1. So it goes down 1 over 1, down 1 over 1. And we have a line, but if you can see the arrows, goes from negative infinity to positive infinity. Thus, the answer for the domain is clearly